Hello everyone, welcome again to the channel. In this video series, we are going to touch upon all the basic concepts of chord equation and visualize them using animations. First, we are going to cover the general form of chord equation, middle term split method to solve it, quadratic formula, roots of chord equations, nature of roots, and last, maxima minima of chord equation. In the first part, we will first understand the chord equations. The general form of a chord equation is ax square plus bx plus c is equal to 0. If you see the first term, here a is the coefficient of x square, b is the coefficient of x, and the third term c is a constant term. Now it is important to note that coefficient of x square cannot be equal to 0. b can be equal to 0, c can be equal to 0, but a cannot be equal to 0. Let us see some examples of these chord equations. So first is 3x square plus 5x plus 10 equal to 0. We can see that if we compare it with the general form, value of a is 3, value of b is 5, and value of c is 10. Another example is x square minus 5x plus 6 equal to 0. Here a is equal to 1, b is equal to minus 5, and c is equal to 6. Another example, x square minus 5x equal to 0. You will note that c is 0 in this case. 2x square minus 16 equal to 0. In this case, b is equal to 0. X square equal to 0. This is also a chord equation. Here b and c both are equal to 0. But in any of these cases, a cannot be equal to 0. Now, one more point to note, you can see that the variable is x and the highest power is 2. Therefore, the number of distinct real roots that we can get will be equal to 2. In this part, we are going to learn how to solve a chord equation. The very first method is splitting the middle term. Let us understand it with an example. So we have an equation x square minus 5x plus 6 equal to 0. We can see that value of a is 1, value of b is minus 5, and value of c is 6. So we need to split that minus 5 into two parts such that the sum of those two numbers should be minus 5 and the product of those two numbers should be a multiplied by c. So here a is 1, c is 6. That means we need a sum to be minus 5 and we need a product to be plus 6. So if we split minus 5, we can say x square minus 3x minus 2x plus 6 equal to 0. That is the split. Now if we take common values, we get x times x minus 3 minus 2 times x minus 3. We can see that x minus 3 is common to both the terms. So we take it common and we get x minus 3 multiplied by x minus 2. Now two brackets multiply and yield 0. That means either x can be equal to 3 or x can be equal to 2. These are the solution to our chord equation. Now, there is one very important shortcut. We need not carry out all these steps. We can solve these type of chord equations in just 3 steps. So all those chord equations which can be solved using middle term split method, we can apply the following shortcut. So the shortcut is step number 1. Identify the split. So we know minus 5 will get split into minus 3 and minus 2. Step number 2, divide by coefficient of x square. In this case, coefficient of x square is 1. So we divide minus 3 and minus 2 by 1. Step number 3, we change the sign. So minus 3 will become 3 and minus 2 will become 2. That is the solution. Sometimes we will get some chord equations in which we will not be able to apply the middle term split method. So for those type of equations, we have another method which is the quadratic formula. We know the general form of chord equation is ax square plus bx plus c equal to 0. The formula is minus b plus minus square root of b square minus 4ac whole divided by 2a. So a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Let us solve one such example. So we have an equation 2x square minus 5x minus 6 equal to 0. where A is 2, B is -5, and C is -6. So we substitute these A, B, C into the formula, we solve it, and we get x equal to 5 plus minus square root of 73 whole divided by 4. So the two values of x we get are 5 plus square root of 73 whole upon 4, or 5 minus square root of 73 whole upon 4. That is the solution to this chord equation. Note that the value of x that we got are irrational numbers. In this part, we will understand the roots and graphs of chordic function. So if we plot a chordic function x square minus 6x plus 8, the graph will look like this. Note that there are 2 points on the x-axis where the graph cuts the x-axis. The points are x equal to 2 and x equal to 4. These 2 points are called the roots of chord equation, which if we solve the equation, we get the same values, x equal to 2 and x equal to 4. So whether you call it a solution or you call it a root, that is basically the same thing. Let us see one more example. So this time we take the function as minus 2x square minus 2x plus 4. So if we plot the graph, we get 2 points, x equal to -2 and x equal to 1. These are the 2 points where the graph cuts the x-axis. So these are the roots of this chordic function. If you solve the equation, let us say minus 2x square minus 2x plus 4 equal to 0, again you will get these two values as the solution. So based on this, two types of graph we can see on the screen. One is called upward parabola and the second one is called the downward parabola. Now what decides whether we get an upward parabola or a downward parabola? So the coefficient of x square decides it. If the coefficient of x square is greater than 0, we get a upward parabola. In the second case, the coefficient of x square is less than 0. Therefore, we have an downward parabola. The roots of chordic functions are often denoted by symbols alpha and beta, and there is some relation between them. So to understand that, we know the general form of a chord equation is ax square plus bx plus c equal to 0. If we divide the whole equation by coefficient of x square, we get x square plus b upon a times x plus c upon a equal to 0. So there are two important formulae. The first one is sum of roots. Sum of root means alpha plus beta, which is equal to minus of b by a. The other important formula is product of roots, which is alpha multiplied by beta, and that is equal to c by a. These two are very important formulae. We will often use them while solving the questions related to chord equation. In this part, we will understand the nature of roots of chord equations. So we know that chord equations have degree 2. Degree 2 means the number of distinct real roots that we can get are equal to 2. Now it is not necessary that we will get 2 roots all the time. There can be some cases where we will get only one distinct real root, or sometimes maybe no real root. Let us see a few examples. So the first equation is x square plus 12x plus 35. The graph of this function intersects the x-axis at 2 points, at x equal to -7 and x equal to -5. That means we got two distinct real roots. If we draw the graph of x square plus 2x plus 1, we see that it cuts the x-axis at only one point, so x equal to -1. If we draw the graph of x square minus 10x plus 26, we can see that it is not intersecting x-axis at all. That means this particular equation has no real roots. It has imaginary or complex roots. Likewise, we can take a few downward parabolas as well. So if we plot minus x square minus 10x minus 24, we see that it cuts the x-axis at 2 points. So it has two distinct real roots. Another graph of minus x square plus 2x minus 1 cuts the x-axis at only 1 point. So it has only one distinct real root. Last example, graph of minus x square plus 10x minus 27. As we can see that it does not cut x-axis at any point. So it has no real root, or we can say it has imaginary or complex roots. Now that we have some examples, let us dig deeper. We know that the quadratic formula is minus b plus minus square root of b square minus 4ac upon 2a. The part within the square root is called the discriminant. So discriminant is b square minus 4ac. Now there can be three cases. If the discriminant is greater than 0, in that case we get real and distinct roots. If discriminant is equal to 0, in that case we get real and equal roots. And the last case, if discriminant is less than 0, then we get imaginary or complex roots. So let's apply this formula to all these 6 cases. In the first example, the value of discriminant is greater than 0. Therefore, we have 2 distinct real roots. In this second example, the value of discriminant is equal to 0. Therefore, we have only one distinct real root. In the third example, the value of discriminant is less than 0. Therefore, we had imaginary or complex roots. In the fourth example, again discriminant is greater than 0. Therefore, we have 2 distinct real roots. In the fifth example, value of discriminant is 0. Therefore, only one real root. And the last example, value of discriminant is less than 0. Therefore, complex or imaginary roots. In this part, we are going to learn how to calculate maximum or minimum values of quadratic equations. Let us see the first example. X square minus 7x plus 10. If we draw the graph, it cuts the x-axis at 2 points, x equal to 2 and x equal to 5. We can see that it is an upward parabola because coefficient of x square is greater than 0. Now, if I have to calculate the minimum value of this graph, the point at which the graph is attaining its minimum value. So we are going to find the value of x where the graph attains its minimum value. We can see that it is exactly between the two given roots, alpha plus beta by 2. That should give us the value of x where the graph attains its minimum value. We can also use a formula which is minus b by 2a. So if we substitute the values of b and a, we get a value of 3.5. So at 3.5, the graph attains its minimum value. Now we want to find out the minimum value of the graph. So to calculate the minimum value of the graph, we can use a formula 4ac minus b square upon 4a. If we plug the values of ABC into the formula, we get the value of minus 2.25. That means at 3.5, the value of graph is minus 2.25. That is the minimum value of this graph. Now, for the maximum value of the graph or the function, we can see that there is no upper limit. Therefore, the maximum value of this particular function will be infinite. Let us take another example. This time we will plot function of minus x square plus 8x minus 12. We can see that the graph cuts x-axis at 2 points, x equal to 2 and x equal to 6. The graph is downward parabola because coefficient of x square is less than 0. In this case, we can see that the graph cannot go upward beyond a certain value. That means there is an upper limit to the graph. That means at x equal to 4, this particular graph attains its maximum value. Now, to find the maximum value of this function, we can again use the same formula which we applied earlier, 4ac minus b square upon 4a. If we plug the values of ABC into the formula, we will get the maximum value that the graph can attain, which in this case is equal to 4. Now, if we see the minimum value of this graph, we can see that there is no lower limit to this graph, right? Therefore, the minimum value of this particular graph is minus infinity. Now let us summarize this. So if we have an upward parabola, the maximum value will be infinity. But there will be a point below which it cannot go. That means we will get a minimum value in that case. In the second case, if we have a downward parabola, it can go down infinitely. Therefore, minimum value will be minus infinity. but there is a upper limit beyond which it cannot go. Therefore, in that case, we will get a maximum value. So depending upon the shape of the parabola, whether it is upward parabola or downward parabola, we can calculate the maximum or minimum value in respective cases.